Okay, so let's have our example now for the Newton-Raphson. This is similar again sa ang previous example, but for this one, we just applied the Newton-Raphson in calculating the root of this specific nonlinear equation. So again, we just have an initial guess. So we know that the correct answer is just around this interval, right? And then ang 0 and then the 2r or the 0.11 is already to maximum no, for our initial guess. So let's say there is no initial guess, then let's have the guess, the initial guess at around at the 0.05. And again, now we have this equation for this for the depth to determine the depth of the floating ball. And then since the Newton-Raphson incorporates the first derivative, so we just apply the first derivative. So we have here that 3x squared minus 0.33x. Okay, so let's arrange this. You have the approximate relative error and then the number of significant digits, then our x, tapos the function and its the function of the first derivative, and then the approximated root. So our first assumption is 0.05. Now we just substitute 0.05 to this equation here and there, and then we arrive with 0.000112 and negative 0.009. So again, the second point, or let's see if this is x1. Oh, let me change this to x1 or x0. It really depends, no, kung unsa yung denote with the first term. So we have the x1 and the x2 is just the x1 minus the function of the x1 over the first derivative of the x1. So the second point here, up to the 3 decimal place, we have 0.062. So that will be our new value of x for the second iteration. So we have the first iteration and then we have the second iteration, 0.062. Now the f of 0.062 is 0.00000 up to the fifth decimal place. And for the f prime x, for this one we have the negative 0.00891. So tanaw ni mo na this is already good as 0, diba? So sa ato pa our x3, this point here is equal to this point. So sa ato pa this is 0.062. If we just continue this, actually same ra gyud po na itong makuha. So sa ato pa at the second iteration, we have already quantified the root of the equation is 0.062m, or the ball submerged at a depth of 6.2 centimeters. Now if we get the approximate relative error for the second iteration, we have 0.072%. Now if we compare it with the old iteration, for the third iteration, this is already 0, close to 0, or 0 if up to the 3 decimal place. So for the first iteration, we have a significant figure. Then for the second iteration, actually the significant figure for this one, if we use the correct value, no, up to the 6th or the 9th significant places, kung bagay siya no mo abot siya, let's say 2. Let's say there is 2 significant digits, but if we use just if we go on with the iteration, no, magbalik-balik na magini siya. Mano gini siya sa ato pa. If we use the formula for dm, again the formula for dm is the 2 minus the logarithm of twice the approximate relative error. Actually, wala tayong makuha, this will become a mathematical error. So sa ato pa, the number of significant digits that we use in this calculation will be the number of correct significant digits for that calculation, or 3. So mo na din to siya. This is the Newton-Raphson method.